In this exam, we're working with US monthly data on employment, unemployment, and earnings by educational attainment. Let's take a look at what those fields look like. We have a year, we have a period, which is a character variable, we have education level earnings, number of unemployed people, number of employed people. So for example, in December 2020, the median earnings of people with less than high school education were $680. There were 8 million of them employed and almost 1 million unemployed. Let's look at question 1. We're supposed to say how many observations we have. So we're going to drag the count field. We have 628 observations. Let's make sure that we understand what is the level of granularity of this data. Let's make year discrete so that we can put it in our rows shelf and have a separate row for each distinct value of year. Let's put period, and we can see that we have 4 observations for each year and each month. Those 4 observations each corresponds to different education level. So the unit of observation is a year, month, and education level. In question 2, we're supposed to plot the level of employment over time. Now, first we're supposed to create a date field. So let's create a calculated field. Let's call it date, and let's use the function make date, which takes as argument year, which we already have. Month we don't have, but we can create month from the period field by taking the 2 rightmost characters, as we did before in class, and the day is going to be first of the month. This calculation is valid. I'm going to say okay. We're going to put date on the columns shelf. We're going to put employment, sum of employment on the rows shelf. Of course, we don't have 1.6 billion people in this country. So clearly, we're adding across all the months for each year. So we need the level of granularity on the x-axis to be the same as the level of granularity of our data. So we're going to make this x-axis continuous by month and year. And indeed, we can see that the level of employment is around 130 million. What happened in April 2020? Of course, we had the shutdown due to the pandemic. Here, I'm just going to say this is COVID, and of course we can make that annotation a lot nicer if we wanted to. There. In question 3, we're supposed to, let me remind myself, we're supposed to create a dimension that labels observations as recession and expansions. So let's do that. Let's create calculated field, call it recession versus expansion. And we're going to use the if function. And if a year is greater than 2008 and year is less than 2020, then we have expansion. Otherwise, we have recession. That's a valid calculation. Let's see how many observations do we have in each category. We've got 528 year, month, and education level observations that happened during expansion, 100 in recession. Excellent. In question 4, we're supposed to create a labor force. Labor force is the sum of unemployed and employed people. Create a visualization showing the share of each education level in the labor force in January 2008 and 2021. So let's first create that labor force field. It's employed plus unemployed. And we want to show them by education level. So let's do labor force, sum of labor force on the rows shelf, but we want to show it only in January 2008 and January 2021. So let's add a filter where we're going to select January 2008 and January 2021. So I'm going to say okay. Fantastic. Of course, we want to separate. We want to have one bar for 2008 and another bar for 2021. So we can put that on the columns shelf. Of course, we could have done that also on the rows shelf. Let's keep it on the columns shelf. Let's switch it back to bars. And let's actually put date onto color so we can see those bars, different years in a different color. And at first, actually, let's flip it this way so that we have 2008 and 2021. Obviously, we had more people in the country in 2021 than in 2008. So that's why I'd like to see what are the shares of a different education level in the overall labor force rather than the plain counts. So we're going to use a table calculation to calculate percent of total. It's going to give us shares, and we want those shares not across the entire table, but rather across each pane, because I want a share of people with a bachelor's degree or higher in 2008 and the same in 2021. So that gives us 35 people with a bachelor degree or higher. Let's actually sort the education level so that it is indeed by education level rather than alphabetical order. So some college should go above high school and below bachelor or higher. Fantastic. We see clearly that the share of people with bachelor's degree has jumped up from 33% to 43%. Share of people with less than high school education dropped from 9% to about 6%. Excellent. In question 5, we're supposed to, let's remind me, unemployment rate. We're supposed to calculate aggregate unemployment rate and plot monthly aggregate unemployment rate. So this calls for another calculated field. In this case, unemployment rate aggregate. We need the sum of unemployed people divided by the sum of the labor force. That's the definition of the unemployment rate. And we're going to put that on rows, and we're going to put the date by month and year on the columns shelf. Let's format unemployment rate as a percentage. Excellent. Let's add a reference line, the average line. You see average monthly unemployment rate 5.5% over this time period. Obviously, we recognize this graph. We had a recession 2008, 2009, and we have a COVID hit in April 2020. So how do I know that I need an aggregate calculation to calculate an aggregate unemployment rate? Well, let's look at the structure of the data. We have one row for each month, year, and unemployment level. To calculate aggregate unemployment rate for each month, I need to add up the total number of people unemployed across the 4 different education levels. So I need to add up these 4 numbers over here and divide that by the sum of these numbers over here. And that's going to give me the aggregate unemployment rate in January 2020. If I do the same thing for February 2020, add up these numbers and divide them by these numbers, I'm going to get the aggregate unemployment rate in February 2020. The resulting data set would look something like this. If I add up the number of unemployed in January 2020, that's 7. 1 plus 2 plus 2 plus 2, that's 7, divided by 90 gives me the aggregate unemployment rate for that month and year, 7.8%. Similarly, for February 2020. And I have my 2 unemployment rates. I have 1 unemployment rate for each year and month. If I average those monthly aggregate unemployment rates, I'm going to get one number, 8.4. I believe that in the real data, it's a 5.5. Taking question 6, we're supposed to create a vertical bar chart where we have an average unemployment rate for each education level over the time period, 1 bar for each education level. So this doesn't call for a aggregate unemployment rate. Here we want the unemployment rate by each education level. So we're going to calculate unemployment rate by just taking the number of unemployed, dividing it by labor force. This is going to be a row level calculation. We're going to have for each month and each year and each education level, we're going to have a separate unemployment rate. And we're going to average those unemployment rates over time. So let's put the education level over on the columns shelf. Let's put unemployment rate, rather average unemployment rate on the rows shelf. Let's again sort education level so that it is indeed in the degree of education, moving some college up there. And nicely we see straight away that the unemployment rate is much higher for lower education levels. What if I need average unemployment rates by education level? Well, I need to calculate the unemployment rate for each month for each education level. And since each month and year and education level is the level of granularity of our data, I can calculate unemployment rate, not as an aggregate expression, but as a row level calculation, simply taking the number of unemployed and dividing it by labor force for each row in our data. Then, if I want to know what is the average unemployment rate for each education level, I need to take the unemployment rate for, let's say, less than high school education level in each of the months that we have in our data. In this case, in the simplified version, only 2 months. So that's 10. And then average unemployment rate in February for less than high school education level was 20. So their average unemployment rate is 15%. For high school educated, we have 10 and we have 10. So average is 10 and so on. And we have here in this table, average unemployment rate for each education level, the average taken over time. What happens if I add a grand total to that table? Well, that's going to average across the entire column of the unemployment rate. It's going to average all of this data, which gives me 10% average. That's certainly a different number from the average aggregate unemployment rate, because the average aggregate unemployment rate weighs different education levels based on how important they are in the labor force. Whereas this average just takes a plain, simple, unweighted average across all the years and all the months and all the education levels. In question 7, we're supposed to add a aggregate bar here. I'm going to label that question 7. So let's go to analysis, so show total, show grand totals, and we see that when we average monthly unemployment rate for each education level, we get 6.5%. And that's a number that's different than what we saw in question 5. Why is it different? Because in question 7, what we're doing is we're taking an unweighted average of the monthly unemployment rate across all education level, weighing people with high school degrees, people with bachelor's degrees equally. But of course, their share in the labor force is different. And therefore, the average unweighted unemployment rate is different from the aggregate unemployment rate, which takes into account the fact that there are more people with bachelor's degree than there are people with less than high school education. Okay, in question 8, we're supposed to create a scatter plot where we put earnings on one axis and the unemployment rate on the other axis. And we want this to be broken down by education level and by date. By date, it's not just a year, but also year and a month. Let's make it a little more informative by mapping education level to color. And we see actually a pattern here. We see that as unemployment rate goes down, earnings start to pick up. That's because when unemployment rate is low, the bargaining position of workers is stronger, and so they can negotiate higher earnings. We also see these odd points over here. Where are they from? Those are 2020 numbers. Those are the high unemployment figures from 2020. Let's actually see if we can map them to a different shape. And indeed, we see that during recessions, that pattern of declining unemployment and rising earnings is broken, but during expansion, we see it very clearly. In question 9, we're supposed to join this data with data on working population. So I'm going to add that connection. It's a text file. It is working age population. The working age population is annual data. So for each year, I just have one observation for population, and it doesn't even go to 2021. And how can we join it with our monthly data on unemployment? Well, there are no common fields, so it doesn't join us automatically, but we know that we have a year field in BLS unemployment data, and we have a date in working age population data. So I can create a joint calculation where from that date, I can extract a year, and that's going to line up those two data sets very nicely. You can see that in December 2020, here's my earnings, unemployment, and employment data, and it's lined up with the working age population during 2020. Of course, it's the same across all the months because it's annual data. It switches when we switch to 2019. So we have to keep that in mind, that the level of granularity in the population data is definitely different from the level of granularity in the unemployment and earnings data. In question 10, we're supposed to plot the labor force participation rate. So let's create that labor force participation rate. And this is going to be an aggregate calculation. We want to take some of the labor force because we want to aggregate across all the education levels. So we want to take the sum of the labor force. We want to add the labor force across different education levels. But for each education level, it's lined up with the aggregate working age population. And so I don't want to add a working age population of 200 million that's lined up with each of the 4 education levels. Instead, I want to take one of those values. So I can take a minimum, I can take a maximum, or I can take an average, and I'll be dividing the aggregate labor force added across the 4 education level by the working age population during that year and month. So let's take average and working age population. We'll say okay to that. We're going to plot that against time and make it monthly. And we see that labor force participation ranges between 60 and 70%, dropping quite significantly during the shutdown. So what happens when I join my original BLS data, where I had 1 row for each education level and each month and each year, with the population data, where I have just 1 row for each year? Well, it'll look like this. If a population in 2020 is 180, and I join it by year with my employment and earnings data by educational attainment, that 180 population is going to repeat across all of the educational level, because in population I have just 1 year, and in 1 year I have a 180, and here for all of these values, for all of these months and all these educational levels, I just have 1 number for population. So population gets duplicated across all the values that match the year 2020. And 2019, if the population in 2019 is different, that's when that number is going to change. So if I'm asked to calculate labor force participation rate in question 10, what I need is I need to add up the labor force in the first month and divide that by population. But I know that I didn't have a population 180 plus 180 plus 180 plus 180. I know that the population in 2020 was just 180. So I need to take the aggregate of labor force. I need to take the sum of labor force, but then I need to divide it not by the sum of population, but rather by, let's say, average of population. If I use the minimum or maximum, I would get the same thing. And so I see that adding up the labor force, it gives me 90. Population in that year was 180. So in that month, the aggregate, this is not unemployment rate, this is labor force participation, was 50%. Similarly, in February 2020, again, adding up, so summing a labor force, but taking average of population, and I calculate next month's labor force participation rate.